Hello students, welcome back. Students, in previous lectures we discussed emission spectrum of hydrogen and hydrogen-like ions. And students, we have also learned that line spectra of atoms of different elements are unique, which means different atoms of different elements have different atomic or line spectra. But students, as the number of electrons in atoms increase, the emission spectra or the line spectra become quite complicated and complex. However, there is regularity in their spectra. Means वो complex जरूर है, complicated जरूर है, but there is a regularity in line spectra of atoms. So students, among all the line spectra, line spectrum of hydrogen is the simplest, and hydrogen-like ions, they also have what? Simplest atomic spectra. But students, the line spectra of hydrogen and hydrogen-like ions cannot be explained on the basis of Rutherford model, because in Rutherford model there was no idea about the discrete energy levels present in an atom. Means electron कौन से energy level में है वो Rutherford model में उसका कोई idea नहीं था. But students, to explain this emission spectrum of hydrogen and hydrogen-like ions, Niels Bohr then postulated that in an atom there are discrete energy levels, and then he put forward a Bohr's model, or we say he postulated or proposed an atomic model which is called Bohr's atomic model. So students, today we are going to discuss Bohr's model of atom. So we are studying now Bohr's model of atom. So students, according to Bohr's model, an atom has nucleus nearly at the center, and electrons revolve around the nucleus in well-defined circular paths. These circular paths are called orbits, and students, these orbits have fixed radius and they have definite energy. So students, the first postulate was that an atom has nucleus at the center, and electrons, they revolve around the nucleus in well-defined circular paths. These circular paths around the nucleus in which electrons revolve are called what? Orbits. Now these orbits, students, they are numbered as 1. So this is the first orbit, this is 2, 3, 4 and 5. And these are designated as, the first orbit is designated as K, then L, M, N, and then alphabetically we follow O and so on. And students, in modern quantum mechanics, all these numbers, these are called principal quantum numbers. Now students, since these orbits, they have fixed radii, so these radii of the orbits were then measured, and we express atomic radius or radius of an orbit Rn, say nth orbit, as 0.529 into n square upon Z angstrom. Now for hydrogen atom, student, we take Z as 1, so the radii of the various orbits are expressed as 0.529 into n square angstrom. Whereas for hydrogen-like ions like helium, lithium and beryllium ions, we also use this Z. Now students, also the energy of these orbits is fixed or definite, and students, energy of an orbit is given by the expression minus 2 pi square m e raised to power 4, then we have z square upon n square and h square. Now students, for hydrogen atom, so for hydrogen atom, see, z we take 1, so energy of say nth orbit will be minus 2 pi square, then mass of electron into charge on electron raised to power 4, z is 1, so 1 square is 1, upon n square into h square. So this is the general expression for energy of nth orbit of hydrogen atom. For hydrogen like ions, आपको z का value accordingly put करना पड़ेगा. Now students, 2 pi mass of electron, charge on electron and Planck's constant, all these are constants. So we simplify this result, that is energy of electron, as minus, so we write a constant RH for all these 2 pi square m e raised to power square 4 upon h square. So we write it as n upon 1 upon n square. So this is students called Rydberg's constant. So ये आपका Rydberg's constant है. Now substituting the values of mass of electron, charge on the electron, students, this RH is found to be minus 2.18 into 10 raised to power minus 18 upon n square. This is joules per atom, or we write it in electron volts as 13.6 upon n square. Electron volts per atom, and students, in kilojoules we can write it as minus 1312 upon n square kilojoules per mole. This is for Avogadro number of atoms. So these results are very, very important. So students, the radius of an orbit is given by this expression. The main expression is this one. For hydrogen atom, z is 1. So this is what we get for hydrogen. Similarly, energy is given by this expression, and then for hydrogen atom, z we put 1, we get this result. On simplification, we say energy of the electron in nth orbit is given by this general expression. This is Rydberg's constant. Substituting value of all the constants, value of RH is found to be 2.18 into 10 raised to power minus 18 joules per atom. Then in electron volts, it is 13.6 electron volts per atom, and in kilojoules per mole, it is 1312 upon n square. Now students, this was for hydrogen. For hydrogen-like ions, now hydrogen-like ions, that is what? Helium positive, lithium 2 positive, beryllium 3 positive ion. Students, the energy of nth orbit is given by minus 2.18 into 10 raised to power minus 18 upon n square into z square joules per atom, or we write it as minus 13.6 into z square upon n square. This is in what? Electron volts per atom. This is electron volts per atom, or we write it as 1312 into z square upon n square, and this is students in kilojoules per mole. This is in kilojoules per mole. Students, similarly, the radii of hydrogen-like ions, they are expressed by this formula. Radius positive ही होगा. It is 0.529 into n square upon z angstrom. So from these results, it is quite clear that जैसे जैसे orbit means orbit का number बढ़ेगा, radius बढ़ेगा, but as z increases, न्यूक्लियस के ऊपर चार्ज बढ़ेगा तो इलेक्ट्रॉन्स आर व्हाट पुल्ड क्लोजर, सो रेडियस घटेगा, मीन z इंक्रीज करेगा तो रेडियस. सिमिलरली स्टूडेंट्स सी इलेक्ट्रॉनिक एनर्जी is given by all these expression, but one thing is clear that एक तो electronic energy is negative, which means electron is bound to the nucleus. जब तक electron nucleus से bound रहेगा, that means electron will be attracted by the nucleus. Energy हमेशा negative ही होगा. But एक चीज clear है students, as z increases, the energy becomes more negative. Means electron और tightly bound होगा. But as n increases, energy becomes less negative, which means जैसे जैसे n बढ़ेगा इलेक्ट्रॉन और न्यूक्लियस के बीच में डिस्टेंस ज्यादा होगा, सो इंटरैक्शन कम होगी, अट्रैक्टिव फोर्सेस कम होने से एनर्जी रिलीज भी कम होगा, सो एनर्जी बिकम्स लेस नेगेटिव. सो स्टूडेंट्स, दिस वाज द फर्स्ट postulate of Bohr's model. Now, what is the second assumption or second postulate of Bohr's model? So, Niels Bohr postulated that, so this is the second postulate of Bohr's model, that energy of electron in an orbit does not change with the time, which means as long as electron remains in a particular orbit, it does not lose or gain energy. So students, understand करो इसको कि जब तक एक इलेक्ट्रॉन एक ऑर्बिट में है, फिर वो चाहे कहीं भी है, उसका एनर्जी सेम रहेगा, टाइम के साथ चेंज नहीं होगा. मींस एक ऑर्बिट में इलेक्ट्रॉन की एनर्जी हमेशा फिक्स्ड है, कांस्टेंट है, चेंज नहीं होगी. दैट मींस स्टूडेंट्स, these orbits have what? Definite energy and it does not change with the time. So that means these orbits can be called as what? Stationary states. So students, this is a very very important point, that orbits are also called stationary states because energy of electron in a particular orbit does not change with the time. And students, since all the orbits, they are associated with definite amount of energy, orbits are also called energy levels or energy shells. So the conclusion is, as long as electron remains in a particular orbit, it does not lose or gain energy. Means अगर सपोज ये न्यूक्लियस है और इलेक्ट्रॉन अगर इस ऑर्बिट में है, सो ये न्यूक्लियस हो गया. इस ऑर्बिट में इलेक्ट्रॉनिक एनर्जी, इलेक्ट्रॉन का एनर्जी टाइम के साथ चेंज नहीं होगा. बट स्टूडेंट्स, से इलेक्ट्रॉन जब सफिशिएंट अमाउंट ऑफ एनर्जी एब्सॉर्ब करेगा तो वो एक लोअर ऑर्बिट से हायर ऑर्बिट में जंप कर सकता है. एंड स्टूडेंट्स, सिमिलरली व्हेन इलेक्ट्रॉन फॉल्स say from higher level to the lower level, the certain amount of energy is emitted. So that means electron can move from what? A lower stationary state to higher stationary state by absorbing what? The certain amount of energy. Means जितना amount required है अगर उतना मिल जाए तो इलेक्ट्रॉन एक ऑर्बिट से दूसरे में जंप कर सकता है. एंड सिमिलरली स्टूडेंट्स, व्हेन इलेक्ट्रॉन फॉल्स फ्रॉम अ हायर स्टेशनरी स्टेट टू अ लोअर स्टेशनरी स्टेट, इट लूजेस एनर्जी. दैट मींस एनर्जी इज एमिटेड. सो बट जब तक इलेक्ट्रॉन एक ऑर्बिट में है तब तक वो एनर्जी लूज या गेन नहीं करेगा. एनर्जी इज ओनली एमिटेड व्हेन इलेक्ट्रॉन्स दे फॉल फ्रॉम हायर ऑर्बिट टू लोअर ऑर्बिट, और इलेक्ट्रॉन्स कैन ओनली मूव फ्रॉम लोअर ऑर्बिट टू higher orbit only when they absorb the energy which is required for this transition. So this was the second postulate. Now students, the third postulate in Bohr's model is that when electrons, they make transition, say from higher levels to lower level, the certain amount of energy is emitted and the frequency of the radiation emitted, that is nu. So this is the third postulate, that the frequency nu of the radiation emitted will be equal to the delta E, that is difference in energy, upon h. Students, ये कहां से आया? So this is very easy. We know that according to Planck's quantum theory, delta E is equal to h nu. So nu will be what? Delta E upon h. Students, Here what is delta E? It is difference in energy, means energy of final state, means जहां से वो आया वो initial और जहां पे आया वो final. So final minus initial upon H. So this is how the frequency of radiation which is emitted during electronic transition can be calculated. Now students, fourth postulate of Bohr's model is very, very important. So Niels Bohr's postulated that only those orbits are permitted in which angular momentum of electron is integral multiple of h upon 2 pi. So fourth postulate is mathematically that angular momentum of electron is always integral multiple of h upon 2 pi. Here n is an integer which can be 1, 2, 3, 4, 5 and so on. And student, this means that angular momentum of electron can be what? In first orbit we put n is equal to 1, so it can be h upon 2 pi. So angular momentum जो electron का वो या तो ये होगा या फिर when we put 2 by 2 is say h upon cancel out, so we get h upon pi. Then in third orbit we put 3, so 3 by 2 is 1.5, so 1.5 into h upon pi. And then in fourth orbit it will be 2h upon pi and so on. So that means angular momentum of electron is also what? Fixed. या तो वो h upon 2 pi होगा या h upon pi, इसके बीच का कोई वैल्यू नहीं होगा, या फिर 1.5 h upon pi, अगेन इन दोनों के बीच का कोई इंटरमीडिएट वैल्यू नहीं होगा. So that means angular momentum of electron in an orbit is quantized, and that is why students this postulate of Bohr's model is called Bohr's postulate of quantization of angular momentum. Student, यहां पर quantized मतलब होता है fixed. This is just like आपका suppose ये एक ladder है, ठीक है, उसमें ये steps बने हैं. That means आप अपना पांव या अपना पैर कहां रख सकते हैं? आप या तो यहां रख सकते हैं या यहां पर रख सकते हैं, इधर रख सकते हैं, इधर या फिर इधर. मीन्स आपके पास ये क्वांटाइज फिक्स स्टेप्स हैं, आप बीच में कोई जगह पे अपना पांव नहीं प्लेस कर सकते. सिमिलरली स्टूडेंट, इलेक्ट्रॉन भी ऐसा ही है, या तो इस ऑर्बिट में, यानी उसका एंगुलर मोमेंटम भी जो है वो भी क्वांटाइज्ड है. दैट इज व्हाई दिस पोस्टुलेट is called Bohr's postulate of quantization of angular momentum. Now students, say if this is nucleus and this is the orbit in which electron revolves and radius is say r, and this electron is moving with velocity say v, then angular momentum at any point will be what? It is m into v, ये तो हो गया linear momentum, so into radius, this is now what? Angular momentum, and this is nh upon 2 pi. So mathematically angular momentum is mvr is equal to nh upon 2 pi. So students, these are the main postulates of Bohr's model. There was another assumption of Niels Bohr's that in any stationary orbit, that is in any stationary state or energy shell, the velocity of electron can be calculated. So we know that mvr is equal to nh upon what? 2 pi. So velocity v from this can be calculated nh upon 2 pi m into r. That is nh upon 2 pi r is what? Circumference. So circumference of the orbit into what? Into mass. So students, किसी भी ऑर्बिट में अब आप वेलोसिटी कैलकुलेट कर सकते हैं. सो जब आप h का वैल्यू पुट करोगे, सो किसी भी ऑर्बिट में ये जो वेलोसिटी ऑफ इलेक्ट्रॉन है स्टूडेंट्स, दिस इज फाउंड टू बी 2.18 into 10 raised to power 6 upon n meter per second. This is for hydrogen atom. So sorry, this is for hydrogen atom. Now students, for hydrogen-like ions, the value of velocity in nth orbit would be 2.18 into 10 raised to power 6 upon n into z meter per second. So again, it means, students, that as n increases, velocity decreases, and as z increases, velocity increases. So these are some key postulates of Bohr's model. Now students, there are some important points which are to be noted, and this is why electronic energy is negative. This you have to understand, students. Students, see, अगर ये न्यूक्लियस है, से ये फर्स्ट ऑर्बिट है. नाउ स्टूडेंट्स, फर्स्ट ऑर्बिट में इलेक्ट्रॉन का एनर्जी से -13.6 अपॉन n स्क्वायर से हाइड्रोजन के लिए करते हैं, सो 1 इलेक्ट्रॉन वोल्ट होगा, सो 13.6 होगा. इलेक्ट्रॉन से सेकेंड ऑर्बिट में है तो इट विल बी 13.6 अपॉन सेकेंड ऑर्बिट में n स्क्वायर, सो 2 स्क्वायर इज 4, सो आपका ये इतना हो जाएगा. दैट मीन्स एज वी मूव अवे फ्रॉम द न्यूक्लियस, अब थर्ड ऑर्बिट में इट विल बी 13.6 अपॉन 9 n स्क्वायर, सो थर्ड ऑर्बिट के लिए n इज 3 स्क्वायर है. सो स्टूडेंट्स, आप एक बात नोट कर रहे हो दैट यहां पर एनर्जी बहुत ज्यादा नेगेटिव था, उसके बाद इट बिकम्स लेस नेगेटिव और ये और कम होता जाएगा. सो एट इनफाइनाइट डिस्टेंस फ्रॉम न्यूक्लियस, से एट इंफिनिटी, स्टूडेंट्स, ये इलेक्ट्रॉन ऑलमोस्ट फ्री होगा. मींस दिस इलेक्ट्रॉन इज नॉट बाउंड टू द न्यूक्लियस. दैट मीन्स इस इलेक्ट्रॉन को ये न्यूक्लियस अट्रैक्ट नहीं कर रहा है. इंटरैक्शन एनर्जी एट दिस पॉइंट इज 0. सो वी से हियर, सो इसका मतलब इलेक्ट्रॉनिक एनर्जी मैक्सिमम कितना हो सकता है? 0. स्टूडेंट्स, और कब होगा ये? व्हेन इलेक्ट्रॉन इज एट इनफाइनाइट डिस्टेंस फ्रॉम द न्यूक्लियस. सो दिस इज कॉल्ड 0 पॉइंट एनर्जी. दैट मीन्स एनर्जी एट इनफाइनाइट डिस्टेंस फ्रॉम द न्यूक्लियस. सो एज नाउ, अब जैसे जैसे इलेक्ट्रॉन न्यूक्लियस के क्लोज आएगा, उसका एनर्जी क्या होता जाएगा? 0 से कम होगा. दिस इज ड्यू टू अट्रैक्शंस बिटवीन न्यूक्लियस एंड द इलेक्ट्रॉन. और 0 से कम होने का मतलब नेगेटिव, और वो जितना ज्यादा नेगेटिव होगा, इट मीन्स इलेक्ट्रॉन उतना ही टाइटली हेल्ड होगा बाय द न्यूक्लियस. सो स्टूडेंट, दैट इज व्हाई इलेक्ट्रॉनिक एनर्जी इज ऑलवेज नेगेटिव, एंड सिग्निफिकेंस ऑफ दिस नेगेटिव साइन इज दैट इलेक्ट्रॉन इज बाउंड टू द न्यूक्लियस. बिकॉज स्टूडेंट, जब इलेक्ट्रॉन बाउंड नहीं होगा तब उसकी एनर्जी कितनी होगी? 0. और जब भी इलेक्ट्रॉन बाउंड होगा, ड्यू टू अट्रैक्शंस बिटवीन न्यूक्लियस एंड द इलेक्ट्रॉन, एनर्जी इज नेगेटिव, और वो जितना ज्यादा क्लोज होगा, एनर्जी उतनी ज्यादा नेगेटिव होगी. वन मोर थिंग स्टूडेंट्स, दैट आपको जब इलेक्ट्रॉन को निकालना होगा फ्रॉम एनी गिवन इलेक्ट्रॉनिक स्टेट, सो उस एनर्जी को हम कहते हैं द मिनिमम एनर्जी रिक्वायर्ड टू रिमूव एन इलेक्ट्रॉन इज कॉल्ड आयनाइजेशन एंथैल्पी. अब उसका मतलब क्या हुआ? दैट इट इज एनर्जी रिक्वायर्ड टू रिमूव एन इलेक्ट्रॉन. से अगर आपने यहां से भी इलेक्ट्रॉन निकाला, ले कहां गए? इंफिनिटी. सो कितना एनर्जी आपको लगाना है इन दोनों लेवल्स के बीच में डिफरेंस, दैट इज ई इंफिनिटी माइनस जहां पर इलेक्ट्रॉन था. बट स्टूडेंट, ये एनर्जी तो 0 होता है, सो 0 माइनस ई एन, सो दिस इज minus of electronic energy. That means ionization energy will always be what? Minus of electronic energy means minus, and electronic energy, say in electron volts, 13.6 upon what? N square into Z square. So we get minus minus plus 13.6 into Z square upon N square. So this is how we find ionization energy. That means energy required to remove an electron from any given stationary state. One more thing, students, which is very important, it is how to calculate number of revolutions made by electron in Bohr's orbit. So students, we call it orbital frequency also, number of revolutions. Now all these results are very very important for competitive exams. So number of revolutions made by electron in any orbit will be always given by velocity of the electron and circumference of the orbit, that is 2 pi r. Now student, velocity का value आपको पता है, radius का value अगर आपको पता है, तो आप number of revolutions which are made by electron in any orbit can be calculated. And students, ये जब calculate करके आएगा तो it will be 6.66 into 10 raised to power 15 upon n cube into z square per second. This is a general expression for hydrogen atom. For hydrogen atom, आपका ये जो ऑर्बिटल फ्रीक्वेंसी है, मींस रेवोल्यूशंस कितने होंगे इलेक्ट्रॉन के, ऑर्बिटल फ्रीक्वेंसी विल बी व्हाट 6.66 into 10 raised to power 15 upon n cube, because z आपका हाइड्रोजन के लिए 1 होगा, so this is per second or in hertz. And for hydrogen like ions आपको z भी पुट करना पड़ेगा. Now students, अगर ऑर्बिटल फ्रीक्वेंसी इतना है तो टाइम पीरियड कितना होगा, मींस टाइम टेकन फॉर वन रेवोल्यूशन. सो स्टूडेंट्स, टाइम पीरियड जो होगा वो रेसिप्रोकल ऑफ ऑर्बिटल फ्रीक्वेंसी होगा. जितना भी ऑर्बिटल फ्रीक्वेंसी है उसका रेसिप्रोकल, दैट मींस आप इसका रेसिप्रोकल लोगे, सो इट विल बी व्हाट n क्यूब अपॉन z स्क्वायर इंटू रेसिप्रोकल, दैट इज 6.66 into 10 raised to power 15. Now it will be in seconds. और हाइड्रोजन के लिए आप z पुट कर देना. So these results are students very very important. Now students, based on all these results or all these postulate, we will discuss numerical problems. Students, so here I have one numerical. The energy associated with the first orbit in the hydrogen atom is minus 2.18 into 10 raised to power minus 18 joules per atom. What is the energy associated with electron in Bohr's fifth orbit? And we have to calculate radius of Bohr's fifth orbit also. Now students, first orbit का energy given है, fifth orbit का energy निकालना है. And we know that generally energy is what? En is equal to minus, say general expression is say 2.18 into 10 raised to power minus 18 upon n square. So students, this is joules per atom. Now first orbit का energy given है, means n is equal to 1 के लिए energy आपके पास given है, तो E1 आपको पता है E5 निकालना है. तो स्टूडेंट्स हम क्या करेंगे, E5 upon E1. Now see this students, आपका ये जो E5 है वो क्या होगा, -2.18 into 10 raised to power minus 18 upon n square, that is 5 square. So that means it will be -2.18 into 10 raised to power minus 18 upon what, 25, and this is 2.18 into 10 raised to power minus 18 upon 1 square is 1. So students, ये cancel हो गया. So which means what, आपका जो फिफ्थ ऑर्बिट का जो एनर्जी है वो 1/25 होगा. सो दैट मीन्स स्टूडेंट्स E5 would be what, 1/25, that is 25 times energy of first orbit. और फर्स्ट ऑर्बिट का एनर्जी स्टूडेंट्स आपको पता है, दैट इज व्हाट, -2.18 into 10 raised to power minus 18 joules per atom. So solving this we get energy of fifth orbit. या तो स्टूडेंट्स ये जो रिजल्ट है ये स्टैंडर्ड ही है, फर्स्ट ऑर्बिट का इतना है तो फिफ्थ ऑर्बिट का कितना होगा, जो ये है डिवाइडेड बाय n स्क्वायर, दैट इज 5 स्क्वायर, 25 कर दो, आंसर आ जाएगा. नाउ स्टूडेंट्स, द सेकंड पार्ट ऑफ द क्वेश्चन इज व्हाट इज द रेडियस ऑफ बोहर्स फिफ्थ ऑर्बिट. सो जनरल एक्सप्रेशन फॉर रेडियस इज दैट रेडियस is 0.529 into n square upon z angstrom. Now since question is regarding hydrogen atom, z we put 1, so it is 0.529 into n square angstrom. So now for fifth orbit R5 कितना होगा, it will be 0.529 into 5 square, that is 25 angstrom. So students, solving this we get radius of fifth orbit. So students, that is all for today. Thank you.